Hey everyone! Ever wondered why some AI image generators create stunning visuals, but fail to align with what humans actually find appealing? Today, we're exploring a groundbreaking approach that's redefining how AI understands human preferences, using a technique called listener-rewarded thinking. Let's dive into the details. Here's the core challenge. AI models trained to generate images or videos from text often struggle to match human aesthetic judgments. Traditional methods rely on supervised fine-tuning, where models memorize examples. But this leads to brittle results, like a student who crams for a test but can't apply knowledge to new problems. Enter reinforcement learning, a method where models learn through trial and error. But even this has a critical flaw. Imagine a student explaining their answer to a teacher, only for the teacher to disagree with the reasoning, even if the answer is correct. That's the issue here. AI models sometimes generate accurate outputs, but with reasoning that clashes with an independent listener model. This creates errors, especially when dealing with novel, unseen data. This is where the listener model steps in. Think of it as a fact-checker. After the AI generates a chain of reasoning, like, this image uses vibrant colors because, the listener, a separate frozen vision language model, VLM, evaluates whether the reasoning holds up. If the listener disagrees, the AI receives a soft reward to refine its thought process. This isn't just about being right, it's about explaining itself in a way that convinces others. The results? This listener-augmented approach shattered the ImageReward benchmark with 67.4% accuracy, a massive leap. It also boosted performance on large datasets by up to 6%, while reducing contradictions in reasoning. It's like giving AI a compass to navigate the nuanced landscape of human taste, even when faced with unfamiliar data. So what's the takeaway? By combining reinforcement learning with listener feedback, researchers are building AI that's not just smart, but persuasive, aligning with human preferences in a scalable way. This has implications for creative tools, virtual assistants, and beyond. But here's the real innovation. The listener isn't just a passive evaluator. It's a dynamic feedback loop. Let's break it down. The AI generates a reasoning chain, the listener scores it based on coherence and alignment with human judgments, and the model adjusts its strategy. This isn't about brute force optimization. It's about teaching AI to think like a human, not just mimic patterns. Testing this on datasets, where humans rated images for aesthetics or prompt alignment, revealed something fascinating. The listener-driven model outperformed traditional methods, especially on unseen data. Why? Because it forced the AI to generalize, not just memorize. For example, if the AI said, "This image is better due to composition," but the listener detected a contradiction in the next sentence, the model learned to self-correct. Of course, this isn't a perfect solution. Some contradictions still emerge, but the listener significantly reduces them. And the implications extend far beyond images. This approach could revolutionize how AI handles math problems, coding, or even everyday instructions. Imagine an AI that doesn't just follow orders, but justifies them, like a helpful assistant who always has a good reason for their suggestions. Now let's talk about the technical heart of this, gradient-based preference optimization, GRPO. Think of it as a training method that teaches AI to listen to human feedback. Instead of memorizing answers, models learn to explain their reasoning, adapt to subtle preferences, and generalize from limited data. This is a game changer because traditional AI systems often struggle with subjective tasks, like detecting when a generated image feels creepy, or a video feels boring, without explicit rules. The scalability of this work is impressive. It's not just effective for text-to-image tools, it could apply to a wide range of applications. Picture a creative artist using AI to brainstorm ideas, knowing the system is tuned to their unique style. Or a developer building an accessible tool for people with visual impairments, where the AI adapts to their specific needs. The key here is generalization. The model learns to apply what it's learned from limited examples to new, real-world scenarios. But there's another layer, data-efficient reinforcement learning. This means these systems don't need massive datasets to improve. Smaller teams or niche applications can leverage this tech, democratizing AI innovation. Plus, the transparency of the listener mechanism builds trust. When you ask, "Why did you generate this?" the model can explain its reasoning, like a student breaking down a math problem. Of course, with great power comes great responsibility. While these advancements could revolutionize fields from entertainment to education, they also raise ethical questions. More capable AI could be misused. Think deepfakes, biased outputs, or misinformation. The researchers behind this work emphasize that technical progress must go hand in hand with ethical safeguards. It's not just about building smarter AI, it's about ensuring it's used responsibly. So what's next? This research is a step toward AI that's not just powerful, but people-centric. But it's up to all of us, developers, users, and policymakers, to shape how these tools evolve. The goal isn't just to create systems that work better,